In a sterile laboratory in the year 2004, a scientist peers through an electron microscope. He is looking at a fragment of a sword from the 10th century. What he expects to see is iron and carbon. Simple, primitive, medieval. What he actually sees shouldn't exist for another 1,000 years. At the molecular level, the blade isn't just steel. It is reinforced with carbon nanotubes, microscopic cylinders of pure carbon, thinner than a human hair but stronger than any material on Earth. This is nanotechnology, the kind of tech we use today to build spacecraft and advanced medical sensors. But this blade was forged in a charcoal fire by a man who couldn't read or write. How did a medieval blacksmith working in the dust of a Damascus bazaar manipulate matter at a scale invisible to the human eye? How did the Romans create a cup that changes color based on the light, using gold particles ground down to the size of a virus? We like to think of history as a slow climb toward the light, but what if the ancients were already standing in the future? The mystery begins with a cup, the Lycurgus cup. To the naked eye, in normal light, it is a dull jade green. It depicts a king being strangled by vines. It's beautiful, sure, but then you place a candle inside it. Suddenly, the glass bleeds. The jade green vanishes, replaced by a deep, glowing ruby red. It's an optical trick so perfect, so precise, that for centuries historians thought it was magic or a fluke. But in 1990, the British Museum broke a tiny piece off to see what was really going on. What they found was a molecular soup. The Romans had infused the glass with silver and gold particles, but they weren't just in the glass. They were ground down to exactly 50 nanometers in diameter. That is 1,000th the size of a grain of salt. If the particles were 60 nanometers, the trick wouldn't work. If they were 40, it would fail. This isn't a happy accident. This is a recipe. But how did they measure something they couldn't see? Now, move forward a few centuries to the Crusades. European knights are clashing with Saracen warriors. The Europeans have heavy, thick broadswords. They are powerful, but they are brittle. Then they encounter the Damascus blade. These swords were legendary. They were said to be able to slice a silk scarf, falling through the air. They could bend 90 degrees and snap back perfectly straight. They never lost their edge, and they bore a strange swirling pattern on the surface, like flowing water or damask fabric. For 500 years, the secret of this steel was the most guarded military asset on the planet. And then, in the 18th century, the recipe vanished. The master smiths died out. The mines ran dry. For 200 years, modern scientists tried to replicate it. They failed every single time. They added more carbon. They tried different cooling methods. Nothing worked. The water pattern was gone. The strength was gone. It was as if a piece of future tech had been dropped into the past and then taken back. But here is where everything we thought about lost technology was wrong. We assumed the secret was in the smithing. We thought the blacksmiths were geniuses who had discovered a secret ritual or a magical flux to add to the fire. But when researchers finally looked at the steel under an electron microscope, they realized the blacksmiths didn't actually know what they were doing, at least not in the way we think. The secret wasn't in the fire. It was in the dirt. The iron ore for Damascus steel came from a very specific mine in India. This ore contained impurities, trace amounts of vanadium and tungsten. When the smiths forged the blades at a very specific low temperature, these impurities aligned. They acted as a catalyst for the carbon. They forced the carbon atoms to form into nanotubes, long hollow cylinders that acted like steel rebars in concrete. The blacksmiths weren't scientists. They were accidental nanotechnologists. They had stumbled upon a biological miracle. They didn't have microscopes. They had feel. They listened to the color of the flame. They smelled the cooling metal. They were operating on a molecular level using nothing but their 5 senses. But there's a darker side to this discovery. Imagine the implications. If the greatest technological advantage in human history was just a lucky impurity in the mud, how many other impossible ancient feats are hidden in plain sight? Take the Roman concrete that survives 2,000 years under seawater, while our modern concrete crumbles in 50.
We recently discovered it contains lime clasts, tiny white chunks we used to think were a sign of poor mixing. Now we know those clasts give the concrete self-healing properties. When a crack forms, water hits the lime, it recrystallizes, and it scabs over. The ancients weren't just lucky, they were masters of observation. They didn't need to see the atom to understand how to manipulate it. They looked at the results, not the theory. While we spend billions on particle accelerators to understand the why, they spent centuries perfecting the how. They were building a world based on the invisible laws of nature, laws we are now only starting to rediscover. But here's the weirdest part. When the specific iron mines in India ran out of that magic ore, the Damascus blades stopped working. The blacksmiths tried everything. They used the same hammers, the same fires, the same techniques, but the nanotubes wouldn't form. The technology died because the biology of the Earth changed. This tells us something terrifying about our own era. We rely on rare earth minerals for our iPhones, our satellites, and our medical tech. We think we're advanced, but like the smiths of Damascus, we are at the mercy of the mud. If our ore runs out tomorrow, our magic disappears. The Lycurgus cup and the Damascus blade aren't just artifacts, they're warnings. They prove that human progress isn't a straight line, it's a series of peaks and valleys. We have been modern before, we have mastered the invisible before, and we have forgotten it all before. The next time you look at an ancient object and think, how could they have been so primitive? Remember the nanotubes. Remember the bleeding glass. We aren't the first ones to touch the future. We are just the latest, and if history is any guide, we won't be the last ones to lose it. The nanotech of the past is still there, buried in the dirt, waiting for someone to find the recipe again. The question is, will we recognize it when we see it, or will we just call it magic?